All right, what I'm going to show you in this video is how we can generate a parabola physically. And so what we have here is a piece of patty paper with a line segment drawn towards the bottom and a point located right here. And what I'm going to do is take this patty paper and I'm going to fold it over so that I can see that point on my line segment. When I can see that point on my line segment, I'm going to form a crease. Now, one of the things you can say about this crease is that this crease is halfway between this point and this line segment. Now what I'm going to do with this is I'm going to do a series of creases where I'm going to shift the left side up and the right side down just a little bit, and I'm going to make another crease. Now what I'm making sure of is that the point remains on the line segment. So I'm going to shift it a little bit more, keeping the point on the line segment, and crease, shift it a little bit more, crease, and you'll notice that every time before I crease, I make sure that that point remains on the line segment. And I'm going to keep making these creases all the way until the point gets to the end of my line segment right there. And so that is the last crease that I will make. Now what I'm going to do is I'm going to come back around to the original crease, which was right here, and I'm going to repeat this procedure except going in the other direction. So I'm going to shift right, up, left, down, and I'm keeping the point on the line segment as I make a series of creases here. And again, every time I'm making sure that that point is on the line segment as I move around here. And then we get to the end of the line segment right here. Now, when I unfold this, you will see the outline of a parabola has been formed. And so what I'm going to do is just take my Sharpie and outline this parabola. Now, before I go any further, one of the things I want to show you is something that I did with a second piece of paper here. And one of the things you'll notice is that when I did these two things, I put the points in different locations. This closer point belongs to this dark parabola, and the lighter point belongs to the lighter parabola underneath. And one of the things you'll notice is that the parabola that's on top, this point is closer to this line segment. And what do you notice about the parabola? It's going to be a narrower parabola than the one underneath. So that's one of the properties that you're going to be working with, is that the closer this point is to this line segment, the narrower your parabola would be. For example, if this point was located right here, that would create a very narrow parabola. All right, so I'm going to come back to this and we're going to look at some other properties and some terms here. This point that we started with actually has a name to it. This is called your focus. This line down here has a name to it also. It is called the directrix. And then you also are going to have a point right here, which everybody should know is called your vertex of your parabola. All right, so let's come up with a definition of a parabola. All right, so let's pick a point somewhere on this parabola over here, and I just put a point on right there. And I'm going to draw a line segment from this focus to that point, and then from this point straight down to my directrix. All right, so let's measure those two segments. You can see that this has a length of 6 centimeters, and the length of this is also 6 centimeters. All right. Now, remember one of the things that we showed earlier at the very beginning was that very first crease, when we folded it over, this first crease was halfway between that focus and your directrix, which means the distance from the focus to this vertex right here is equal to the distance from the vertex to the directrix. That distance has a label that is often referred to as P, which means this also has a length of P, which means the distance from the focus to the directrix would be a length of 2P. Now, it doesn't matter where you pick a point on your parabola. I could pick a point that was way up here. If I measure the distance from the focus to that point, this looks like it's about a 7.3 or so. And then from that straight down, you can see it's also the same distance, 7.3 centimeters. So every point on the parabola, it doesn't matter where you do it, the distance from the focus to that point will be equal to the distance from that point straight down. That actually builds your definition of a parabola. It is the set of all points that are equidistant from a fixed point called the focus and a fixed line segment called your directrix. Now, there is also another line segment that is going to go through the focus that we need to pay attention to, and it goes from one side of your parabola to the other side, passing through the focus, and that line segment has a name to it called the latus rectum. Well, we know the distance from the focus to a point on the parabola is equal to the distance from that point straight down to your directrix. Well, this distance right here is 2P, which means the distance from here to here is also 2P. Well, that gives us the length of the latus rectum would be the total length across, which would be 4P. And because this is a distance, we're going to refer to this as the absolute value of 4P because distances are always positive. Now, in your vertex form of a parabola, which is y equals a x minus h squared plus k. H is your shift left or right on the graph. K is your shift up or down on the graph, which also determines where your vertex is located. A is your vertical stretch or compression. It also does a reflection. But on your vertical stretches and compressions, remember that those determine how wide and narrow your graph is going to be, which means it is directly related to the length of this latus rectum. And so the length of this will help to determine this value of A. Now the relationship between A and this length is that A is equal to 1 over 4P. And so if you know what the latus rectum is, A will be equal to 1 over that length. So if the latus rectum has a length of 12, then A would equal 1 over 12. and your p-value would be 3, which would be from here to here would be 3, and from here to here would also be 3. All right, so those are some things that you need to make sure that you know the relationships of and the definitions of. Your directrix and your focus are the two things we started with. Those are what are necessary in order to be able to create a parabola. And your parabola is just simply the set of all points that are equidistant from the focus and the directrix.